Hello students, welcome to this short video on how to analyze our jumping spider project data. I want to open up the analysis worksheet for our jumping spider data. Remember that we're interested in sorting out how body size influences male contest behavior and the outcome of such contests. And second, how does the presence of female cues alter the contest behavior in males, or does it, right? We're going to be doing a set of inferential statistics to analyze these data. There are some worksheets or documents that help you work through some of the different kinds of tests that we'll be using. They're in this introduction here, they're listed here, there's a link to them, and it helps you also understand how to do these analyses in SPSS. But I thought I'd work with you on a little bit of the analysis, kind of get you started with this video. Oh, one other thing to note, and this is kind of important, I'm highlighting it here. We're going to use a p-value of less than or equal to 0.1 or 10% as the threshold for rejecting the null hypothesis, right? So if our p-value is less than 0.01, that's usually, that's 0.1, sorry, that's exciting. That means that our data support our alternative hypotheses that, yeah, these animals differ. The size affects their behavior, or female cues affects their behavior in a contest. We'll find out. So we're going to take a look at the analyses, and if you scroll through the analysis sheet, you're going to see a couple of things. There are a set of questions that we try to address. The first one here is, were spiders that won the contests larger than spiders that lost the contests? And there are places for you to fill in information. This is where you'll be doing this as a group. So you're going to put all your data into this worksheet and then submit it at some point. Every single analysis also asks you to make a graph in Excel and insert it into this document and then submit it. Here's a second analysis, a third analysis, and finally a fourth one. So there's going to be kind of 4 different analyses that you'll be doing, or sets of analyses, okay? I want to walk you through one of them, just so that you can get a feeling for what we're doing. So the first thing that we were looking at is, does body size affect contest outcome or behaviors during a contest? And one of the questions we could ask is, hey, were spiders that won the contests larger than spiders that lost the contests? In this case, we'd have to think about, what's the size of the winners versus the size of the losers? We have these data. They're in our SPSS spreadsheet. So I think I'm going to put down here, and you can put this in any color you want. Oh, I'm going to put down for my variables the size of the winners. I guess I could put length of the winners because we really measured the length, didn't we, of the losers. Okay. So the length of the winners versus the length of the losers. I think we called it size of winners and size of losers on our SPSS spreadsheet. And what we're going to do is we're going to compare these two groups to see if the winners are, in fact, tend to be bigger than the losers. That's what I would predict. That would be my alternative hypothesis, right? So let's take a look at the data, and then we need to think about what kind of test would I perform to compare the size of the winners versus the size of the losers in these paired contests. You know, in each contest, we did 10 contests, and in each of them there's a pair, right? One is a winner and one is a loser. We want to compare their lengths or their sizes. In our SPSS spreadsheet, I've got a spreadsheet that I made with the data that Dr. Henshaw and I collected, and it has all the same things on it that your spreadsheet should have, right? Treatment, who won, this would be the larger animal won, the smaller animal won, and then all sorts of data that we collected. But way at the very end is the size of the winner and the size of the loser. These are the two columns we want to compare. We're interested in finding out if winners tend to be bigger than losers. I kind of think they will be, but I don't know. What kind of test could compare the means of two groups that are not independent of each other? They're dependent on each, they're not independent of each other, they're paired. A paired t-test would be able to compare the means of two groups. We want to know if the two groups differ in their mean values. And I think this would be a paired t-test because we've got pairs of males. In each contest, we have what is going to become a winner and a loser, and their behavior might depend upon each other. If the winner is really aggressive, the loser might be really submissive, something like that, right? So they're paired. The data aren't independent of each other. So now I have to find the place to do a paired t-test. And I go to Analyze up here on my menu. And I have lots of options, right? But I want to compare the means of these two groups. And I want to do, and notice there's lots of different t-test options, right? That's what comparing the means of two groups would involve. But I want to do a paired samples t-test because I've got samples that are in fact paired together. Oh, well, I've already put these in because I was practicing. Let me just delete these. So what I need to do is find the two variables that I want to compare. And I scroll down to the bottom because I know I want to compare the size of the winner versus the size of the loser. And ask the question, are these two groups different from each other? So all I need to do in this case is hit OK. And what I like about the paired t-test, if you look at the output, you will see a lot of things that you're going to need to put into your data sheet. Now these are my data. Your data will be slightly different because you collected it and we're probably not perfectly consistent in our collection, all right? So these are the data that we collected. I've got the means and the standard error of the mean. These are the two things I need to report on my analysis worksheet. It looks like the winners are a little bigger than the losers, but are they significantly different from each other? Well, we don't need to use this box. We scroll down here to the paired samples t-test data. And what we're looking for here are these last three boxes, or these last three columns. The t-value for these data are 2.7. The degrees of freedom is 9. There were 10 groups. 10 minus 1 is 9 degrees of freedom. And here it is. The p-value, or significance, is 0.024. All right, I'm going to take all these data and put them into my analysis sheet, and then I have to think about what it means. So let me skip over to my analysis sheet. So what kind of test would I use? I'm going to use a paired t-test. What are my data? Well, my winner size, the winner sizes, I'm spelling everything wrong, you can figure that out, was 12.15 with a standard error 0.54. The loser size was 11 point, these are my data, these are not your data. You should not have the same exact numbers, most likely. They'll be similar. Use the same videos, right? And then I ran the paired t-test and I found that the t-value was t is equal to 2.72, the degrees of freedom was 9, and the p-value was 0.024. Notice I put, before the decimal, I put a 0. That makes it easier for me to read the decimal place, right? Yes, guess what? Now I can interpret my findings. That's down here. Before we get to the graph, let's think about what this means. Well, if the p-value is less than 0.1 is what we're using, then we say, these data, it looks like we need to reject our null hypothesis. But that's a bunch of statistical kind of, we don't like that. So I would say, wow, these data show that the two groups are significantly different from each other. Or at least I should say something like that. The data support our hypothesis that larger spiders are more likely to win. In a paired contest, how about that? That in a paired contest, larger spiders are more, I like that, likely to win contests than smaller spiders. period. And then my t-value, t equals 2.7. Oh, I would have to write, you know, paired t-test, t equals 2.72. This just shows us that we have all of our ducks in a row, and we know we want to insert, when we're interpreting our findings, we want to insert our statistics, degrees of freedom, and our p-value. This is kind of the important one, is 0.024. What that tells me is that there's a very small probability, that's what the p-value is, right? There's a very small probability that the differences we see are just due to chance. So yeah, we see differences in the winners and the losers. The winners seem to be bigger. The differences that we see here are probably not just due to chance, because our p-value is so small. That's great. It means that there's probably some real reason why winners tend to be bigger than losers. Winners tend to be bigger than losers, okay? So I'm going to write something like this down. I think that's better than saying don't reject the null hypothesis. Now I need to make a graph of these data. It says what kind of graph would best depict these findings? Which variables would be on the x and the y axis? Oops, that's a question mark, right? Make the graph and insert it here. Well, what would be the best way to show these data? It's pretty simple data. We have winners and losers, mean size of the winners and mean size of the losers, right? And then their error bars. We could just make this a bar graph. So I'm going to go to Excel and make a bar graph. And I have to think about the dependent variable being on the y-axis. The dependent variable is what we measure. The independent variable goes on the x-axis. That's the variable that we can change, basically. We either have large or small animals. So the size, so the spider, whether they're winners or losers, would go on the y-axis, x-axis. I said that wrong. Let's start over when we start making it. That was a mistake. I don't want to stop my whole video and start fresh, right? Okay, so I'm thinking I could make a simple bar graph to compare the two different types of spiders, either winners and losers. That would be on the x-axis. These are the independent variables. The variable I measured, the length of the animals, would be on the y-axis. The mean length in millimeters is really what I measured. So I put these data into two columns. I always put the independent variable first and the dependent variable second. That's just how it works. And then I can highlight these columns. I highlight all the words as well, the titles. And I think I want to do a bar graph. So I'm going to go to my insert menu, and there are different graphs and types of charts and stuff you can do. I'm going to do just a basic bar graph. Whoa, and it automatically pops up. It's beautiful. And it's not quite right. I really don't want a title. I really don't. So I'm clicking on something I don't want and just clicking delete. I don't want these random horizontal grid lines, so I'm going to delete them. I do, however, want an X and a Y axis label, so I'm going to need to go to my chart elements, click on axes titles, definitely put them in. My one title here, let's see, what shall we call this? This would be the mean spider length in millimeters, plus or minus length, plus, I'm going to add in the error bars, plus or minus the standard error bars in millimeters. There we go, that's nice. This axis title can just be like spider, okay? I might want to make those a little bit bigger. To do that, I think I can just click on them and change the font size. Whoa, maybe that's too big, I don't know, something like that. You can make your own decisions on that, okay? Making them look prettier if you need to. Okay, I need to do one more thing, and I need to add the error bars to my graph. And you can nicely see that the winners look much bigger than the losers, but notice my y-axis there is pretty small. It starts at 11.3. Either way, I like it so far. I'm going to add in error bars. So I click on my graph, I go to the chart elements plus icon, and I go to error bars. It automatically puts on random error bars. I hate that. So we want to go to more options. Click on the triangle, go to more options, And then it tells us that we're using a fixed value. I don't want to use a fixed value. I want to put in my own error bars. So I go to custom error bars, specify value, and I've already put my error bars in a separate column over here. For my positive error bar, I want the values to be 0.54 and 0.55. For my negative error bar, I want the same values to show up, right? I'm going up and going down from the mean. And their 0.54 and 0.55 are very similar, so we're not going to be able to tell the difference on those. But we did it. There's our graph. And our data suggest that winners are statistically different from losers. Winners are statistically larger than losers are. At least the data suggests that, right? Okay, beautiful. Now I'm ready to move on to my second analysis. So now I have to go back to my analysis sheet, all right? And I would start my next analysis, okay? And analysis 2 says, did the winning and losing males behave differently? All right, so now we have to look at all of the behaviors and compare winners to losers. Remember all those behaviors that you carefully collected data on, like explore, orient, approach, retreat, leg fencing, and grappling. We could compare the behaviors of the winners to the losers for each of our 10 trials and calculate means. So we're going to use a lot of variables here. You could probably just write that in, a lot of behavioral variables, right, to compare winners to losers. Again, we're going to compare winners to losers that are paired. We had paired contests. So if we're comparing the mean values of winners to losers, what do you think we're going to use? What type of test here? All right. Take a look at the rest of analysis 2 on your own, and this is going to involve doing 1, 2, 3, 4, 5, 6 analyses. They're all the same. You can actually put them into SPSS, analyze them all at the same time if you want to, or separately. And you're going to put all your data here. Look at the p-values. Look for significant p-values. Look for values that are less than 0.1 is what we've decided. And talk about what they mean. Right? If the p-values are less than 0.1, we would say that the two groups are significantly different from each other. Maybe winners are more likely to grapple than losers, although they seem to do that equally. Maybe winners are more likely to approach than losers. Or maybe losers are more likely to retreat than winners. You'll have to find out. I want to look at analysis 3 together before I finish the video. It says, did the presence of female cues alter the behavior of the males? Oh yeah, remember in half of our trials, 5 of our trials, we had female cues before the trial began, and in half of them there were no female cues. So we've got sample sizes of 5 trials in which there were female cues and 5 trials in which there weren't any female cues. It says for this analysis, we're going to compare the sums of behaviors of both males, like winners and losers. And if you want to compare winners and like the total amount of retreat behaviors, the total amount of explore behaviors, for example, that's what we want to do. Except we want to compare trials in which there were female cues to trials in which there weren't female cues. And you can get a hint here about the analysis by looking at the table that you need to fill in. What kind of variables are we going to use? Well, we're going to look at explore, orient, approach, retreat, leg fencing, and grappling. But this time, we're going to add up the behaviors, like the winner and the loser. Total approach behaviors, total retreats. Are there more leg fences? Or I would kind of predict that there might be, like the fight might be longer if there were female cues present, right? And so there would be maybe more approaches and maybe more leg fences or more grappling maybe than when there are no female cues present, because the males would have something to fight about. There would be a big thing at stake, maybe the ability to find a female and mate with her, right? So I would expect to see more aggressive behaviors when female cues are present than when female cues are absent. That's what I'd be looking for. To do this test, you actually have to calculate new variables. And what I want to do is I want to add up the total number of, say, grapples that winners and losers make. Okay. Let me go to my spreadsheet. Okay. I have these data, and remember, female treatment here is important because you either did not have female cues, that would be a 0, or you did have female cues in your trial. And you can see there are 5 trials with no female cues and 5 trials with female cues. What we're going to do is we're going to compare those trials we're comparing the means in these trials. And guess what? When you compare the means of 2 groups, you're looking at a t-test. But this t-test is comparing independent samples. We've got some trials with no females, some trials with females. So we're going to do an independent samples t-test. Now, in order to add up, I'm just going to do one of them. I want to look at grappling behavior between, I want to look at grappling behavior, and I'm assuming there's going to be more grappling when females are present. At least that's my hypothesis. To add up grappling behavior for winners and losers for each contest, I'm going to have to compute a new variable. So I'm going to need to go to Transform, Compute Variable. All right, I'm going to call this maybe total grappling behavior. And my numeric expression would be the grappling behavior of winner plus the grappling behavior of the loser. Oh wait, here it is. Winner grapple, and I click the arrow, and then I put plus loser grapple. Loser grapple. I can click my arrow and it pops up. And that's what it is. And it tells me that I computed this variable. If I look at my data, how do I get out of this again? If I look at my data, I should see in the very last column a brand new total. Ooh, total grappling. Notice one thing though, it should be a scale variable, not a nominal variable. So I'm going to have to change that. I go to my variable view, I change it to scale. Okay. Now I'm ready to compare my 2 groups. I have total grappling. Oh, there's not much grappling. I'm just not sure that that's right. Let's double check on that. I just want to make sure that I've got grappling here. Oh yeah, in my first trial there was no grappling. Okay, I guess it can happen. Okay, so I've got here. I've got my set. Now all I need to do is an independent t-test to compare my 2 groups of males that had different experiences, right? No female cues, female cues. So I go to Analyze, I go to Compare Means, Independent Samples t-test, and the test variable, I want to make sure that I just want to get this out of here. I practiced this, of course, before I started. The test variable would be, I think, the total grappling. Ching. And I want to do an independent t-test, but I have to tell you what is the grouping variable. How am I going to group the data? Well, I want to group the data by my female treatment. Did I have a female cues or not female cues, right? I have to define my groups. I used 0s and 1s, and so my group 1, 0 would be no females. My group 2 would be the number 1, okay? I put those in, and now I'm ready to go. Here comes my paired t-test, my independent t-test, people. In my independent t-test, I have, I have very big differences here in the means of grappling. With no females, the average was 4.4 grapples. In the female cue, the average was 93.6 grapple behaviors. This is hugely different. I'm expecting a big difference here, okay? Now I need to go to my independent samples test box, and I'm going to assume that the variances are equal. So use the first row here, equal variances assumed. And what I need to look for is my t-value, negative 2.597. My degrees of freedom are 8, and my p-value or significance is 0.032. That's small. No surprise since these numbers are so different, right? So what that tells me is these 2 groups are significantly different from each other. In other words, it looks like when female cues are present, males are much more likely to grapple. than when no female cues are present. The data support our hypothesis that the presence of female cues is going to affect grappling behavior. Pretty cool. You can do this for all of the behaviors that we studied to see what, maybe that's 5 or 6 different independent t-tests that you'll have to run. And look at the data, report the data, and move on to the next analysis. Well, talk about the data, think about how you're going to graph the data. Whew, you got a lot to do. This is exciting, though. This is my favorite part in some ways. When you're done with analysis 3, you'll move on to analysis 4. Develop a new analysis to address a question that your group chooses. You get to pick a question and figure out how to analyze it. Yikes. Do the analysis. Tell us what your statistics are. Make a graph and tell us what you found for analysis 4. So when you're all done, you're going to have 4 analyses completed. You're going to have 4 figures. You don't need to make figure captions at this point, but usually your captions are going to be a lot about interpreting your findings. They're going to be short statements that describe what's going on in your graph. And we'll work on that next time. We'll talk about good captions to make for your figures. I think that's it for now. I hope that this all worked well, and I hope it's helpful. Thanks.